Welcome to Electrolyzing Water with me, Paul Seaver, from Palm Beach Springs Water Company. So this is the first video in this series, and I'm going to start with electrolyzed water for consumption. That's what a lot of people know about. That's what they have the most questions about. You know, there's a lot of units on the market. The most popular one out there is Kagan because they got the best marketing plan. So just to simplify this video, I'm just going to kind of make some comparisons, and I might use that name, but all those are pretty much the same. They're a single polarity membrane system that separates out the acidic and electrolyzes the basic to make a higher pH ionized water, a nano water, with and also includes hydrogen. So you're making hydrogen at that higher pH in the basic range. And so what I'm going to do is I'm going to talk about what's the difference between this unit here, Esperer.H2O, a Japanese technology, and all the rest of them, because this is a standalone unit. So first off, where does Esperer come from? So Esperer is a French word. It means to bring hope through water. Esperer.H2O, to bring hope through water. So Esperer.H2O was developed by a PhD scientist in Japan named Dr. Hanoka. So he owns the patents on it, and he's considered to be the foremost authority, especially on advanced electrochemistry in the world. And his basic proof of that is that he has the most powerful and most advanced electrochemistry unit for water technology in the world. So one of the biggest differences between the two is this unit is dual polarity. It uses both negative and positive charges, where the units like Kagan and the rest of them use a single polarity. They're only using a negative charge. So the negative charge is where you get your hydrogen from. The positive charge is where you get your reactive oxygen from. So just on that subject alone, being able to produce both reactive oxygen and hydrogen in the same space at the same time separates these units from single polarity units. So the advantage is, how do you balance hydrogen and how do you watch that finger. How do you balance hydrogen and how do you balance reactive oxygen? The interaction between the two. So then you're going to go back to oxygen, or in this case, since it's in water, you're going to go back to H2O. So hydrogen plus reactive oxygen, water. Okay, so that's the balance. So you're taking a negative component, the hydrogen, and a positive component, the reactive oxygen, and you're joining them together. They cancel each other out. But in this case, it goes a little further than that. But that's very important, because in those other units, what they're doing is they're delivering to you a high pH alkaline water, which, number one, is too high pH for a human body. That's why you're only supposed to drink so much of it per day. Anything more than that's an excess. What happens in an excess? Well, the first problem in the chain is it inhibits your cell's ability to process their own waste. So that starts a cascade of problems. But you know, you probably have to drink a lot for quite a period of time to initiate that kind of stuff. But that's the answer to the question. That's the first thing that happens. So your body's at about 7.4 pH. That's what pH it wants everything at. That's its neutral. So in single polarity alkaline ionizers, you can't achieve that. You're going to be much higher. You're 10 or better. Okay, so that's no good. The other thing is you're getting too much hydrogen. The hydrogen's not balanced. Now, how are you making hydrogen reactive oxygen? You're making it through sodium chloride that's present in the water. Okay, you're using the natural elements in the water. How does your body produce these things naturally? Sodium chloride. We put our salt on our food or whatever, drink our water. You know, we call it electrolytes. So you're getting it through your electrolytes. Hey, dogs. So if you flood your body with oxygen, your body has the ability to produce reactant. If you flood your body with hydrogen, your body has the ability to produce reactive oxygen and neutralize it out. So you're doing the opposite of what you're trying to do. You're trying to pull that hydrogen in to neutralize free radicals or reactive oxygen. So if you only flood your body full of hydrogen and produce reactive oxygen, you're doing the opposite of what you're looking to do. So the difference with the Esperer unit right here is by it producing reactive oxygen and hydrogen at the same time using dual polarity, it's balancing it. So you're getting a balanced hydrogen, reactive oxygen, and oxygen. So as your body is getting this all balanced, it can use it as a ready-to-go fuel. It doesn't have to process nothing. It doesn't have to counterbalance nothing. No matter how much you're getting of one thing, you're getting the balance of the other. Okay? So that's the big difference between the two, right there, just in that subject alone having to do with gases produced by H2O. Because that's what all these things do in electrochemistry. What you're doing is you're producing gases, okay? And then you're using these gases. And then the ions, you're using them for a bunch of stuff. You're using it for delivery, but we'll get into all that. So anyway, when it comes to high alkaline hydrogen water, you only are advised to drink so much of it for the reason that I just explained to you. Now, this unit here, drink it all day long. Use it for everything. There's no limitations on it other than the limit of the human body's intake of water per day, period, which everybody's a little bit different. There's a standard rate on it. You're not supposed to consume like more than 2 liters per day, or you can end up having some problems with consuming too much water. Yep, even water you can consume too much of. So everything has to be in balance. All right, coffee. It's still early. Let's let my lights on. So that's the difference in the gases. Now let's talk about the difference in the ionization, as they call it, ionizers. I like to separate myself by calling myself an electrolyzer. So then people say, well, what's the difference between electrolyzing and ionizing? But you could use the term either way. So, water. Fellas, I'm trying to make a video here. Could you please? They have to play by my feet. I was going to lock them out of here, but I got to have the fan running. It's too hot. Anyway, ionizers. So water at ambient temperature is clustered. Typically 13 to 15 molecules, mixed molecules, roughly, if it's perfect. Half of them will be acidic, half of them will be basic. That's where you get your pH from, measuring the difference between the two. The acidic is the pKa, the basic is the pKb, or the alkaline is the pKb. So the power difference between the two of them is where you get your pH. pH scale is from 0 to 14. 0 is acidic, 14 is basic, alkaline. Okay? Neutral in that category is 7. You'd have 7 basic and 7 acidic molecules. That's called pKw, the potential for neutral in water. Okay, so that's regular water that everybody has, coming in from your faucet, sitting out there in the lake, sitting down in the well. That's it. So at ambient temperature, it's clustered. Raise the temperature and you reduce the clusters. Now, everybody understands that from cooking. So when you put the water on the stove and you turn up the temperature, it starts to boil, all of a sudden steam starts to rise. That's because you're eliminating the clustering and all sorts of other things, and you're being able to release single molecules and single ions, okay? Well, maybe not the ions, but the molecules anyway. Now, what's the opposite? The opposite is when you drop the temperature. Now the clustering becomes so thick, it turns into ice. And it actually has strength. You could drive a truck on it if it's a frozen lake, all right? So that's the difference that temperature makes in water. It could either turn it into a gas, or it could turn it into a solid feature. So that's using temperature. So what happens if you can't use temperature? What happens if you need to manipulate those ions and make them and reduce those clusters and free everything up, and you can't add heat. So that's where electrochemistry comes in. Okay, so in single polarity, you can take that 13 to 15 molecules and break it up into what they call nano, 5 molecules. Still unbalanced because they're all clustered together, and you did nothing to separate the acidic from the basic. Now, in those ionizers like the Kagan with the membrane, it does have some separation. That's how it's able to bust it down to nano, but it's not perfect. It's not perfect. In order to be perfect, you have to have a charge on both sides. If you have a charge on one side, you're pulling all your basic over there, but you're going to have a couple stragglers come with it because you got nothing to keep them from doing it. Okay? So you got a strong positive charge here pulling all the, or you got a strong negative charge here pulling all the positive particles to it, changing your polarity. On the other side, you got nothing. Okay? I think I just messed that up a little bit, but anyway, you can follow along. It's a little too complicated. Anyway, you have one side's attracted particles to make high alkaline. The other side's not doing anything. It's using it as waste. Now, they make a play on that waste, being that it's an acidic pH, and they say it's a sanitizer, but good luck. Okay? If you put it in a bottle and put a label on it, you'd never be able to call it a sanitizer, not in a million years. They can call it that because they don't make a product. Okay, but generally it's just wastewater. So the difference is when you have an anode and a cathode, you're pulling all your basic to your cathode, you're making basic at your cathode, you're making acidic at your anode. So now you're using both sides, you get a perfect, absolutely perfect separation. Okay? So when you do that, you could do different things. Now, you have them separated, you can put equal charge on them in both their polarities. Once you do that, you can join them back together and they're going to match up 1 for 1. So that's bonded 1 for 1 pKw neutral. Now you have a single ion rather than 2 ions. So in a single polarity ionizer, you end up with a nanocluster and wastewater. In this generator, you end up with 1 water in, 1 water out, single ion, single molecule, no clusters. So that's the difference between single polarity and dual polarity. So with this technology, once you have achieved rebonding them back together into a single ion, you can pick the polarity that's dominant. So you can either pick positive or you can pick negative. In the case of this, we're picking negative because you want it in the alkaline range. Now, since we're joining, this gets super complicated, I understand, but hey, you want to know what this stuff is, why it's not a gimmick, I got to get into all of it. And so once you take an acidic ion and a basic ion and you put them together, they're neutral. They're neutral, that's it. They're going to be neutral, and we're going to put a little bit more of a negative charge on there. We're stabilizing the pH at 7.4, which is the same as exactly what's required for the human body. Now, those gases that we talked about are all there, but they're also there at the correct pH. So you're able to use the hydrogen, the oxygen, and even the reactive oxygen. Your body uses reactive oxygen, otherwise you wouldn't have free radicals. It's important, but we're not going to get into that portion. Everything's important. If it's natural, it's important. Your body uses it. It's just a matter of what it does with it, how much it has, and if it's causing you a problem. Because what you're doing at this other oxidation is you're not getting it from sodium chloride. You're getting it from other sources. Okay, so that's why we're not going to get into that portion. It gets a little bit tricky. Okay, some stuff is good for us, some stuff is not good for us. All depends on the source that you get it from, which is very important when it comes to electrolyzers. So that's it on gases, and that's it on ionization. What's the difference between nano and ionic? Ionic is a single molecule dissolved, a single ion dissolved in a single molecule of water. Nano is a cluster of molecules and components grouped together. Now the difference between the two is one is very easily absorbed, which really comes into play with cleaning a lot more and the other is not. So your aquaporins will only allow you to absorb a single molecule at a time. So if you have a cluster of molecules, that's why when you drink bottled water and stuff, it goes right to the gut. That's why. When you sip Esperer, you never feel it in your stomach, you're absorbing it all. So anyway, that's another whole deal about it. Now, electrolyzing. I'll touch on this very briefly because this video is already 15 minutes long, and then I'm going to cut it out of here, and we can just build on this subject, but this is more of an introduction to Esperer. So electrolyzing. Now, my specialty is research and developing a system that I have that's being tested now for removing forever chemicals from water, PFAS chemicals. So that's the nastiest thing you have to worry about in water. With my system, Esperer system here, I use double coconut carbon block. What's the reason? The reason is coconut carbon block is the #1 media for absorbing chemicals that are in water. Nothing beats it. It's like 98% effective. I double up on it. Why? First one catches 98%, leaves 2% behind, right? Second one catches 98% of the 2%. I mean, by then it's ridiculous. You're down into the quadrillions, so it really doesn't matter anymore. You're way, way, way down, people. Okay, so double coconut carbon block is perfect. Now, why is it important with electrolyzers? The chemicals get their power from hydrogen. That's what really binds their power. It's at the head of the chemical. It's like the head of your body is a hydrogen molecule, and that's what holds its power, which gives it the power, because hydrogen is more powerful than anything. So when you electrolyze, you're increasing the potential of the hydrogen. You're increasing the potential of the chemical. Number one. Number two, depending on what kind of system you have, we'll just leave it at that. You're increasing the potential of the chemicals. So the one thing you want to do is you want to get the chemicals out of your water. The last thing you want to do is increase their potential, make them stronger. So whenever you have an electrolyzer hooked up, make sure you have no less than double coconut carbon block. You have one coming in to knock out 98% of it before it's even going through your electrolyzer, and one going out to not only pick up whatever's left behind, but also whatever else. You got descaling and stuff going on from these things if they're automatically cleaning like this one is, so you have to have something on the end. And the coconut carbon block just makes the water taste better. So anyway, that's pretty much it. I'm going to leave this for right here today. So we covered, what's the difference between nano electrolyzer like a Kagan, an Esperer electrolyzer that's dual polarity, ionics, the difference in the gases. With single polarity, you only get hydrogen. With dual polarity, you get hydrogen, reactive oxygen, balanced to oxygen is the byproduct. The ionic product with Kagans and the ionizers, you get 1.37 nano. With dual polarity, you get 6.45 ionic. That's just how much energy's in the water. The ion sizing, with nano you get a cluster. With this you get a single ion at 0.0001 micron. Isn't that small? That's what can make it through your aquaporins. You get the balanced pH rather than the high pH. So that's the difference between a nano system that you typically find everywhere and this patented system from Japan that you can only get from Japan. That's it, period. It only comes from this one company. That's the only company that can manufacture them because it's patented. You can't patent general electrochemistry, but this isn't general, this is advanced. So anyway, best system on the market. Stay tuned. I'm going to talk more about Esperer, but I'm going to let this one go for now, and have a great day.